next talk is from Max. Max, thanks so much for joining us. And yeah, we're excited to have you talk as well. Do you want to get your slides up?
Yeah, let's do it.
Right. The floor is yours.
Cool. Yeah, thank you so much for having me. My name is Max Gerber. I'm an engineer at Stitch, and today I'm here to talk about what client ID metadata documents mean for MCP. There's going to be a lot of acronyms today. So first, quick stop, what is Stitch? Stitch is a developer platform for building identity experiences for humans, machines, and agents. So we help with things like your login and sign-up flow, dealing with user credentials, as well as a lot of integrations with open standards like SCIM, SSO, SAML, OIDC. We help with stuff like fraud and device intelligence. And the team that I work on deals mostly with MCP authentication. So we also help people become OAuth compliant authorization servers so that they can run MCP flows in the cloud safely and securely. So today we're going to talk about dynamic client registration and kind of the history of it, how it ended up in MCP, and how it limits the adoption of MCP today. We're going to talk about client ID metadata documents, a new standard that is hoping to unseat dynamic client registration and improve the ecosystem. We'll talk about how to support CIMD as an MCP client, as well as an authorization server. And then I'll give my hot takes about what's going to come next in the MCP ecosystem. So first, dynamic client registration. How do we get here? Let's do a quick OAuth terminology refresher. In an OAuth flow, an OAuth client is an application that wants to access a user's data, which is served by a resource server. The resource server is only going to give up that data if the OAuth client can present a valid access token. So the OAuth client needs to go to an authorization server, also called an identity provider. The identity provider is going to validate the end user's identity and is going to ask them, do you consent to share your data with this client? If the user consents, the authorization server issues an access token to the client, and then the client can read the user's data. My favorite example of OAuth in everyday life is logging into Netflix on your TV. Because you go to your TV, and your TV directs you to netflix.com. And you say, yes, I want to watch Netflix from my TV. And then Netflix issues an access token to your TV, your client, and then you can go watch movies. But you don't ever share your password with your TV. Now, mapping this into the MCP ecosystem, resource servers are MCP servers, and OAuth clients are MCP clients. Now, in traditional OAuth, developers know in advance who they're going to be integrating with. So if I'm a developer and I want to call the GitHub API, I can go to GitHub and register for a client ID, a way to identify the client that I want to use to access user data. So on the left here, I've got the GitHub OAuth signup screen. And on the right, I've got the Google Cloud signup screen. And virtually every single authorization server out there has a screen like this, where developers come in and say, this is my application, this is where it runs online, and please give me a client ID that I can use to ask users for permission to access their data. And in a traditional OAuth development, developers are only integrating with a handful of APIs at a time. And so developers plan ahead who they're going to be integrating with, and they actually want to have a relationship with GitHub, the company. So creating a GitHub OAuth client once isn't that big of a deal. But MCP kind of throws this on its head, because MCP clients don't know what MCP servers they're going to talk to. And these servers can be added or removed on the fly. And this is one of the core proposals of the MCP protocol. And so this manual client registration step is really bad for mass MCP adoption. If I am an MCP client developer and I'm working on ChatGPT or Claude Code or Goose or another client, I don't want to go and pre-register these clients in every MCP server or authorization server that exists. I checked on Pulse MCP this morning. There's over 200 remote MCP servers. That would be a lot of clicking around to get everything set up. At the same time, registering by end users, asking them to perform the registration, wouldn't work well either, because many users of MCP servers are non-technical. And if the process of trying out a new MCP server means that you need to create a developer account, fill out a form, and so on, it's going to be very high friction. So when the MCP OAuth scheme was first proposed, dynamic client registration kind of came into the forte. So dynamic client registration is an existing OAuth standard for creating these clients on the fly via an API call. And this means that MCP clients like Claude Code or Cursor could go and send a post request to an endpoint and receive a new client ID at any time. And this takes out the headache from manual registration. However, it also introduces a lot of new headaches. And there's a really, really good blog on the Model Context Protocol website that goes into what these headaches are. But there's two main categories. One is that this endpoint is really hard to operate. Because there's no authentication and anyone can call and get a new client ID, the number of clients keeps growing unbounded. And tracking and managing all of these clients is really hard. If every single one of your users using Claude Code is registering its own Claude Code client, it makes it pretty difficult to detect how many people are using Claude Code. And if you're a user, it makes it hard to understand how your data is being shared. Additionally, dynamic client registration has a lot of concerns around phishing. Clients can say who they are. They can say, I am Claude, these are my URLs, but how do we know if they're lying? With a manual registration process, there's checks in place for manual review. There's a real human with an email that you can reach out to and talk to at the other end, but we don't have that here. This means that malware can pretend to be Claude Code and can impersonate it and attempt to access your account. And headaches like these have prevented a lot of authorization servers from implementing dynamic client registration. And that prevents a lot of businesses from shipping MCP servers. So client ID metadata documents are hopefully going to give us a way out. CIMD is a new specification from 𝗷𝗶𝗶𝗃𝗃 and Amelia Smith, and it was originally used in the @proto or the Blue Sky community. With client ID metadata, client information is hosted at a publicly available URL. And then the client can use that URL as its client ID. Authorization servers will see that the client ID is a URL and dynamically pull this information in to create the client on the fly. But the really nice thing is that the URL has a domain name in it. And this means that authorization servers and users can base their trust on that domain name. If the domain name is chatgpt.com, you know with a lot of certainty that the client is ChatGPT and not someone impersonating ChatGPT. So going back to the problems we discussed before, this gets rid of the operational problems. Each client is registered exactly once using a unique URL, and all of the concerns around database growth and duplicate clients go away. And phishing is eliminated in most cases, not all. Because we can trust the domain name, cloud-based clients like Claude and ChatGPT can no longer be impersonated. However, local clients like Claude Code that are running on localhost can still be affected. However, I think this is going to de-risk MCP adoption for many companies. So if you're a client implementer, what does this look like? It's pretty simple. You're going to take your existing dynamic client registration payload and you're going to put it on the internet. When you start an OAuth flow with an authorization server, there's going to be a field in the authorization server metadata that determines whether or not the server supports CIMD. And if it does, then you use your CIMD URL as your client ID and you're done. If not, then you should reach out to the authorization server, tell them to support CIMD because it's better than DCR. And then you can always fall back to DCR like people are doing today. So this is the code to implement CIMD for one of our example apps that we're going to be showing later. And it's just a blob of JSON in our public directory. So let's say you're an authorization server and you want to implement CIMD. What does that look like? So when a client ID comes in on an OAuth flow, you're going to want to check if it's an HTTPS URL and fetch the payload. And you want to be sure to make sure that you're only fetching an HTTP URL. If someone sends you another URL scheme like a file URL or an email, just ignore it. You want to make sure that you're only fetching after authenticating the end user, so you're not tricked into doing work by someone who hasn't even logged in yet. And then you're going to want to validate the client metadata that's returned and use it to render your OAuth consent screen. And there's a lot of flexibility in how you validate the metadata. You might say, I only want my server to be open to ChatGPT, Claude, Cursor, and other well-known clients. Or you might have a different strategy. Or if you're an internal in an enterprise, you might have other considerations to deal with. You're going to want to think about devising a caching strategy because this metadata can change over time. And you definitely don't want to fetch the metadata on every single authorization request. But if it has cache control headers, then you can use that to determine when the metadata becomes stale and when you need to refetch it. Or maybe you're going to refetch it at an interval, like every 15 minutes or so. Finally, you're going to want to look at server-side request forgery, or SSRF, which is an attack where an attacker tricks you to make requests inside your own network. So if I say that my client ID metadata URL is running on 0000, I can trick you into making requests that you wouldn't want to make. And in order to mitigate this, check the IP address of the resolved hostname and make sure it doesn't resolve to a private IP. There's a lot that goes into that and a lot of careful considerations, but there's a really good blog on Stytch.com about securing APIs against SSRF that I recommend you check out. And big disclaimer, consider using an existing OAuth authorization server instead of building it yourself. While CIMD is not particularly hard to implement, many other parts of OAuth are, and even small mistakes can have serious consequences for end users. Obviously, I'm a little biased towards Stitch, but consider everyone else in the market, 𝗬𝗓, 𝗕scope, 𝗃𝗏, etc. So I think that CIMD solves client impersonation for web clients like ChatGPT or Claude Web, but not really for local clients like Claude Code. But I still think that a lot of mass consumer adoption is going to come primarily from these web clients. Think new developments like the ChatGPT Apps SDK. And we still need some more additional tools, which are coming, like software attestation, to enable local clients to prove who they are. And so in the short term, I think that local MCP clients are still going to remain with highly technical users and developer tools. So a couple of links. We've got the Model Context Protocol blog that goes into more details around client registration in the MCP ecosystem. We've got client.dev, which is a microsite that has a lot more information about CIMD. And of course, check out Stitch.com to learn more about Stitch. Now, let's see if we can do a demo. So this is client.dev. And this gives us a good overview of how CIMD works, as well as a couple of specific examples. Client.dev is an OAuth client using CIMD. So if I go to this URL, then we get our client result. That's not that interesting. What's more interesting? Let's say I am building a CIMD compatible authorization server, and I want to go and test out that flow. I can use client.dev as an OAuth client. And we also have a sample OAuth authorization server here for you as well, login.client.dev. So when I kick off this button, this is going to start an OAuth authorization flow using the client.dev CIMD URL as the client ID. And now we see, oh, I'm in a new tab. Let's do a little flip-flop. Can you see my tab?
Yes, we can.
All right.
We're seeing consent flow. Is that what you want us to see?
Yeah. Can you see the URL up here?
No, it's hidden.
Ah, well, you're going to have to trust me. The client ID in the URL is that JSON blob where we were looking at previously, the URL of that JSON blob. And so the authorization server in the background was able to pull in that information dynamically to register this consent screen. And now when I hit allow, information gets granted to the client and we get redirected back to where we started. So definitely check out client.dev. I think it has good resources for people who are both building OAuth clients using CIMD, as well as people who are building OAuth servers that want to support CIMD, or if you want to test an existing server today. The whole site is open source, so also feel free to contribute. We definitely would love to, have input from the community, improve wording on the site, add more security information, and so on. So,
awesome. Max, thanks so much for sharing all this. It was really educational. Darren, any questions you want to dive in with?
So does this address, like, one of the big challenges that we see is when people, they post an MCP server, but then they require registration of like the clients. So it's, they whitelist who's allowed to access it. Like, does this protocol in any way make it such that companies don't have to do that? Like they can just say, any MCP client could now like OAuth?
Yeah, so there's 3 ways that people are doing client registration today. There's that manual process, the kind of classic way to do it. And that's where people kind of, tamp down on things.
But even because like with DCR, like, so then it's still like because a couple, like there's quite a few we've ran into where it's like, well, you first have to go and say, this is my domain that you allow me to do dynamic client registration with. So that they will only trust certain clients, and then you're allowed to do it. So it's like, it doesn't require that, like, client ID and secret, like the old traditional OAuth, but they still lock it down because they're concerned, whatever security issues.
Yeah. People are generally very concerned about DCR. Like, there are a lot of security and operational headaches with it. I think that client ID metadata is, again, still based on the domain, still based on the URL that you're sending over. And so people can still choose to make those decisions. But what I think we're going to see in the future is a registry of clients, the same way that we have a registry of servers. So there's a place where you can pull in, these are the lists of all of the MCP client URLs that I can expect. Let me see if the community trusts them. And if the community trusts them and they're validated, then yeah, sure, full throttle ahead. But servers will still have the ability to deny a request to a client. If I go and I spin up an OAuth flow with 𝗔𝗶𝗲𝗏.com and the server says, well, I don't trust 𝗔𝗶𝗏𝗏.com, I'm not going to let you access this user data, that's their ability, that's their prerogative.
So what's kind of different here? Because like the thing that's kind of frustrating to me is, like, today in the normal internet, your browsers, servers, and you have a client, like, which is the person, right? There's no inherent trust with the client. Whereas with agents, and what we've now done is we somehow have to trust this intermediate agent, such that I can't create this like open web anymore. Like, it's still a restricted, because that's like the big problem is, I don't care so much about like gatekeepers, like, but just this idea of like, how does it flourish if there has to be a governing, because it's like, as you point out, we have DNS. Like, we have DNS, which is like, ironically, the only trust system that exists in the world, right? And we all trust it. So how do we, like, is there a path towards like anybody could have an agent? And it seems like we're still not quite there. It's still, we're going to have trusted relationships from service provider to like agent, and then to the actual end user.
Yeah. I mean, I think no matter what, there's always going to be trust relationships in place.
Oh yeah.
I do think that things are getting a little bit better, and there's a lot of interesting proposals. And I'm really glad you brought up DNS. This is an attempt to pull like DNS and domain trust into the OAuth registration process. And so I think it's a little step in the right direction. I don't think it fixes everything.
Yeah, I mean, and it's interesting. I didn't know this came from the Blue Sky like app program, because one of the things I loved is they solved the whole handle. How do you verify the user, like the blue check mark type thing? And it's like, well, if the handle's on a DNS, like they just tied it to DNS. And it's like, well, we trust DNS, and so I love that. So I just wonder if there's some solution that we can get to where that the MCP client, which is this kind of strange technical artifact that sits in between the service and the user, is that the service doesn't have to trust the client, the user has to trust the client. And the way the user can trust the client is through is through a domain. So they,
Yeah.
If they go to evil.com, then they're like, well, I trusted you, because that's what you have on the internet today. It's like, I can go to evil.com and I'm just a dumb user who trusted something I shouldn't have trusted, right? Yeah, where we don't, anyways, I love to see it, but I like, so we've implemented DCR, we've done all this, we've been through this kind of madness. I'm glad to see, I'm glad this looks much better. It's a shame that even MCP is like, within, 6 months or something, we already have like 2 legacies of like, oh no, that's the old way to do it. It's like, but anyways.
Yeah. The way I've been describing it is, do you remember in COVID, there was that massive toilet paper shortage?
Oh yeah, of course. Who
Because
doesn't remember that?
people went out and they were like, oh my gosh, I need toilet paper. I need to get it. I need it now. And they were, selling out the stores. And then after the stores got toilet paper back, people just didn't buy toilet paper for like 6 months because they had pulled all of that demand forward. All of like, oh, you always knew you needed this, but you didn't know you needed it today. And that's where I feel where we are with OAuth and security and AI and agents is all of these problems around maintaining, who has access to your data. How do you know that they have access? How do you trust them or not trust them? Like that's always been a thing. That was a thing 5 years ago. But AI and the demand for it has pulled that so much closer to today that now we need to solve all these things now. And it's just, it's like living in a pressure cooker. And I find it very fun. I'm sure other people have different opinions on it.
Yeah, well, I've never seen OAuth move so fast. So it's something is different here to see, people do. So I'm enjoying it, and it's amazing to me how we standardize JSON formats and URLs. It's like the complexity of a JSON format and a URL with arguments. But anyways, query
well, it's the complexity of convincing 7 billion people that this is what the URL should look like and this is what the JSON should look like. I think convincing 7 billion people of anything is going to be very hard.
Yeah.
Max, thanks so much for coming on the Context and sharing what you guys have been working on CIMD with us.